Mr. Wright here, and welcome to this film in which I'll run through some IGCSE questions on circles, finding the areas of circles, the circumferences of circles, and using those two formulas to answer problems. These questions are grades 4 to 6. If you're after something more feisty, then there's another film in the playlist where I run through some questions which are sort of grades 7, 8, and 9. If you're sticking with this film, you'll find the questions by hitting the link in the description. You can download the questions, have a go at them, and then watch the film, or you can work your way through the questions as you watch the film and work alongside me, whatever works for you. If you find the film useful, go on, hit like, give me some positive feedback. Questions or any suggestions, please feel free to leave me a comment, and of course, I'll respond. Okay, let's get on with the maths. Question 1. Right, the diagram shows a circle and a trapezium. The height of the trapezium is h. Okay, the area of the circle is equal to the area of the trapezium. Work out the value of h, right? Well, first of all, let's work out the area of that circle. So the area of the circle is pi r squared, and the radius of the circle is 8.5. So the area of my circle is going to be pi times 8.5 squared. Now, it doesn't matter what that is at the moment, but we could work that out on our calculator. Now, what about this trapezium here? Now, the area of that trapezium is going to be the average of the lengths here. So the average of 20 and 25 multiplied by h. So the area of the trapezium is 20 plus 25 divided by 2 multiplied by h. That's the area of the trapezium. Well, 20 plus 25 divided by 2 is 22.5. So the area of the trapezium is 22.5 h. And I know that the area of the trapezium, 22.5 h, is equal to the area of the circle. So I can write this equation here, and now I just need to divide both sides by 22.5 to find h. So h is going to be pi times 8.5 squared divided by 22.5. So put that into your calculator very carefully, and you'll get an answer on your calculator of 10.08 with many more digits, and we're asked to give our answer correct to one decimal place. So the answer is 10.1. That is question 1. Question 2. Right, the diagram shows a shape made up of 3 semicircles enclosing a right-angled triangle. Okay, now the straight lines here, the edges of the triangle, are each a diameter of this semicircle, and you know that this length is 6 and this length is 6. Okay, we've got to work out the perimeter of the shape. Right, well, first of all, I think I can work out this length here and also that length, because each of those blue lengths there is half a circumference. So the circumference of the circle is pi times the diameter, and the diameter is 6, pi times 6, and each of those is a semicircle. So I could do one of the semicircles plus another of the semicircles, or I could just imagine that both of those semicircles together make a circle, and I could just do the circumference of the whole circle. It doesn't matter whether I use this or whether I do half of it plus another half of it. That's those blue highlighted lengths sorted. Now, the only other part of the perimeter of the shape is this yellow semicircle here. Now, how am I going to find the length of that? I really need to know its diameter. So I really need to know this length here, the length AB. Now I can find AB because I can use Pythagoras on that right-angled triangle. So AB, which is the diameter of my circle, I'll call it D. So the diameter of the circle there is going to be the square root of 6 squared plus 6 squared. So that's the square root of 72. So now I know the diameter of the circle is the square root of 72. So that yellow highlighted semicircle is going to have a length of pi times the diameter, but of course it's only a semicircle, divided by 2. So now I need to write an expression for the perimeter of the whole shape. So the perimeter of the whole shape is going to be the blue semicircle, and then another blue semicircle, plus the yellow semicircle. And that's what I need to work out. And if you put that in your calculator, carefully does it, you get the answer 32.17, and so on. And we're asked to give the answer correct to 1 decimal place. So my answer is going to be 32.2 centimetres. Question 3. Right, the diagram shows a shape made from a square, ABCD, there it is in the middle, and 4 identical semicircles. Okay, now the area of the square is 36 square centimetres, and I need to calculate the total area of the shape. Give your answer correct to 1 decimal place. Now, the total area of the shape. Well, let's have a look. The shape is made up of, it's got a square in the middle, hasn't it, first of all? Well, I know the area of the square. I know the area of the square is 36. So now I really need to find out the area of each of those semicircles. Now, they're all identical, so I could just focus on one of the semicircles here. How do I find the area of a semicircle? Well, I need to know its radius, don't I? So I'll need to know this length here. That's the radius of the circle. How am I going to find that length there? Well, if the square's got an area of 36, then it must be a 6 by 6 square, in which case that radius must be 3. So this blue, this arrowed semicircle here, which I've arrowed with the blue arrow, that's going to have an area of pi times 3 squared, pi r squared over 2. So what I've got for the area of the whole shape is I've got the red square in the middle, and then I've got 4 of those semicircles. So I'm just going to write that the area of the whole shape is going to be 36 plus pi times 3 squared over 2, and another pi times 3 squared over 2, and another pi times 3 squared over 2, and another pi times 3 squared over 2. You're probably just thinking, why doesn't he just combine those semicircles and have 2 full circles? And of course you could do that. Right, if I put all that into my calculator, I get the answer 92.54 with lots more digits. So to 1 decimal place, my answer is 92.5 square centimetres. Question 4. Right, in this question I've got a sector of a circle. Okay, and the centre of the circle is at O. Right, I've got some measurements which are given to me here, and they're marked on the diagram, and I need to calculate the area of this sector. Well, let's have a think about the whole circle. I'm going to draw a dreadful diagram now of the whole circle. You can imagine the whole circle. Now, that area of the whole circle would be pi times r squared, which would be pi times 7.1 squared. So that's the whole circle, but of course I've only got a certain fraction of the circle here. Now what fraction have I got? Well, the trick is to look at the angle at the centre here, because you've got 110 degrees, and the whole circle would have been 360 degrees. So the area of our sector is a certain fraction of the whole circle. It's 110 degrees out of 360 of the whole circle. So the area is going to be 110 360ths of the area of the whole circle. So this expression here is what I need to put into my calculator. Or, of course, you can work out the area of the whole circle, divide it by 360 and multiply it by 110. If you put that into your calculator, whichever way you choose to do it, you get the answer 48.39 and so on. And so to 1 decimal place, the answer is 48.4 square centimetres. Question 5. Right, I've got a circle here, and its diameter is the line AOC, and I've got some measurements which are shown on the diagram, and I've got an angle which is shown on the diagram. And the question is, work out the total area of the regions which are shaded in the diagram. Give your answer to 3 significant figures. Right, now the area that's shaded, well, that's going to be the area of the whole circle. Subtract the area of the right-angled triangle. So I better work out those 2 areas. So the first thing I'm going to need to know is I need to be able to work out the area of the circle. So that's going to be pi r squared, of course, but I wish I knew r. This is the radius here, and I don't know that length. But I can use Pythagoras to find the whole of that length there. Okay, let's have a look at that. So the whole of that length, AC, I'll call that D, the diameter. So the diameter is going to be the square root of 8 squared plus 15 squared. Now, if you put that into a calculator and square root it, then you find that the diameter is 17, which means that the radius is half of 17, of course, which is 8.5. So now I do know the radius of my circle, and so I can write down that the area of the whole circle is pi times 8.5 squared. So there's the area of the whole circle. Good. Right. Now, what about the area of the triangle? Well, the area of a triangle is base times height divided by 2. And in this case, I know that the base is 8, the height is 15, and so I can divide that by 2. So that tells me that the area of the whole triangle, the triangle there, is 60. So my shaded area is going to be, the shaded area is going to be the area of the circle. Now, of course, you could have worked that out on your calculator, but I haven't bothered to do that yet. Take away the area of the triangle. So now if I put that into my calculator, carefully does it, I get the answer 166.98 with many more digits. Shows to 3 significant figures. That's 167 square centimeters is my answer for that question. Question 6. Right, I've got a path here, a diagram of a path, and it tells me that the path is made up of 2 semicircles with the same center. Yeah, I can see that from the diagram. And the path also has 2 straight lines. Yes, it does. Look, there are these straight lines here. Okay, right. The inner semicircle has a radius of 7. That's this semicircle here. It's got a radius of 7. Okay, and the path has a width of 2 meters, so that length there is 2. Work out the perimeter of the path. All right. Well, let's work out, first of all, that red semicircle here, that inner semicircle, which I'm just drawing again there. How long is that line going to be? Well, it's half a diameter of a circle, isn't it? So that's going to be pi d. What is the diameter? Well, the radius is 7, so the diameter is 14. So that semicircle is pi d over 2. Pi times 14 and then halved. Good, so that's that red one done. Right, now, what about this blue semicircle here? Better find the length of that, hadn't I? Okay, now that blue semicircle, what's that radius going to be? Well, the radius is from here all the way to here, so the radius is 9, so the diameter is 18. So that blue semicircle has a length of pi times 18 divided by 2. So far, down here, I've written the length of the blue semicircle, and I've added the length of the red semicircle. Okay, now, is that the perimeter of the whole path? No, because I haven't yet counted this length or this length. Now, each of those lengths are 2, so I'll need to add 4 onto my perimeter here. So now that's an expression for the perimeter of the whole path. So put that into your calculator carefully, and you'll get the answer 54.26 with many more digits. And I'm asked to give the answer correct to 1 decimal place, so that's 54.3. Question 7. Right, the diagram shows the sector of a circle with a radius of 7. And I see, look, there's 7 marked on the diagram. Okay, I'm also told, look, that angle is 50. Right, work out the length of the arc of the sector. Now, what does that mean, the length of the arc?
What it's asking me to do is it's asking me to work out this yellow length here. All right. Now, that yellow length is part of the circumference of the whole circle. So I could work out the circumference of the whole circle. The circumference of this whole circle is pi times d. Now that's the centre of the circle there. So it's got a radius of 7, look. So the diameter of the whole circle would be 14. So the circumference of the whole circle is pi times 14. Great. I haven't got a whole circle here, have I? This yellow shaded section of the circumference is a certain fraction of the circumference. What fraction is it? Well, it's 50 degrees out of 360. So the length of the arc is going to not be pi times 14, because that would be the whole of the circumference. It's only 50 360ths of that. So there's an expression for the length of the arc. And so what I need to do now is to put that in my calculator. It carefully does it, and I get the answer 6.108 on my calculator. So give that to one decimal place. The answer is 6.1 centimetres. Question 8. Right, the diagram shows the sector of a circle with a centre O, and I'm given some measurements here which, look, they appear on the diagram. The 5.2, of course, is the radius, isn't it? Calculate the perimeter of the sector. Give your answer correct to 3 significant figures. The perimeter of the sector, what's that going to mean? Well, that's going to mean the length all the way around. So it's going to mean this length. Oh, by the way, that's 5.2. Plus this section of the circumference, this curved length. I'll do that with a blue highlight for a moment. Plus this length here. Oh, that's 5.2 as well. So the perimeter so far is going to be 5.2 plus 5.2, but then I need to add that section of the circumference onto that. So how am I going to find that length of that blue highlighted section of the circumference? Well, I know the circumference of the whole circle is pi times d, and d in this case is 10.4 because 5.2 is the radius. So I know the circumference of the whole circle is pi times 10.4, but I haven't got the whole circumference, have I? I've got just a certain fraction of it. What fraction? 67 degrees out of 360. So this blue arc has a length of 67 out of 360 times the whole circumference. Right, so what I'm going to need to do for the perimeter is I'm going to need to have the straight length plus the straight length plus the blue arc. So into my calculator, I'm going to carefully type in 5.2 plus 5.2 plus, I'll probably be using the fractions function on my calculator here, or perhaps I'd work out the blue length separately on my calculator and then add on the two 5.2s. Either way, I hope you get the answer 16.48 and so on. And we have to give that answer to 3 significant figures. So the answer is 16.5 centimetres.
Right, well done for making it through those. I hope you're feeling more confident with those questions on areas and circumferences of circles. If you are feeling confident and you would like to have a shot at the harder questions, grades 7, 8 and 9, then stick with the playlist because the next film is a run through of those harder questions. In the meantime, if you are taking your IGCSE quite soon, then subscribe to the channel. There's lots more content to help you. Thanks for watching. See you in the next film.